okay, and how do I organize the data in different format, and how it will be going to affect your algorithm. So the best way, if you organize the data, that well you can design your algorithms. So that's the idea of data, and then going for organizing that data into proper formats. So we will start with the data. So data is, as it is shown here, it is consisting of the various values collected for the different objects. So they are describing the properties of the object, or the data is collected from the different experiments and so on. So you can collect the data from the various sources. Okay, so one of the easiest way to store this data is in terms of the record. Okay, now you can see that records are stored like here. Okay, now it consists of the different attributes. So there are columns, and the column consisting of the attribute, and those are also called as features. Okay, now if you take a look at these data, it has a different type of data like numerical values. Okay, there are some data, it is also called as nominal values. Okay, categorical values, and all these are describing one or two object or the properties of the objects. Okay, now so attribute values, what are the different attributes, the values that attribute can take? Okay, so there are distinction between what is attribute and what is the attribute value. Now if I go back to the previous slide, okay, and look at here, there are attributes which are describing the column itself, like for example refund, which is the column name, that becomes the attribute, and what are the different values it is taking, that is nothing but the attribute values. Similarly for the marital status, taxable income, cheat or no cheat, so that create the complete data set. Okay, so once you have the data, you can go for doing many of the data mining tasks on the given data. Okay, now different attribute can be mapped to the same set of values. Okay, that is possible because the values how it is taking, the attribute can be distinct. Okay, for example taxable income, it is taking the real values. Okay, the price or the how the catalog is given the prices, or that these are the numerical value or the attribute that takes the numerical values. Now it is very interesting, how do you map the values in the table? If I have a table it consisting of the different attributes, and I would like to map this. Okay, I would like to assign the values to those attributes. So there are different ways in which I can assign the values. Suppose I have taken 5 different type of lines. Okay, each one is having a different length. Okay, so it is as listed here. One way is that I just measure the length of those lines and store them. That would be the easiest way to do that, but it has no inherent characteristic of showing the difference between what previous line was and the next line. So there is no ordering is existing in that case. But if you would like to store the order also and the length of the line also, okay, both together, it is possible to store in terms of the record. How do I do that? I can say give the numbering for that. For example, I have given here shown the length with having the smallest one is given the number 1. The line with the length having the next one is given 2, 3 and 4, so on. Okay, here the inherent order that exists in the line is also mapped along with those lengths. So there are various ways in which you can store these records. Okay, in the table, how do you construct the table? That matters a lot in the data mining tasks. Okay, so there are 4 different categories of values of attributes. Okay, one, it is starting from nominal, ordinal, interval, and final one is ratio. Okay, so there are, if you take a look at all the data that exists, they fall under any one of this category. So let us see what are nominal. What do you mean by nominal, or what do you mean by ratio value? Let us start with the ratio. Okay, it's very simple to understand a ratio. Okay, say for example, if I take ratio, there are the temperatures. Say suppose there is a temperature varying along the different time. Okay, this is the time along the x-axis, and the temperature is measured along x-axis. So what it is exactly creating, okay, so this kind of a value, and each value is like a 26.5 degrees Celsius or any value here. Okay, they create ratio. Okay, so many of the operations are on ratio data is valid. Say for example, if I take 26.5 degrees centigrade, okay, and if I would like to add 1 degree to the next one, so I would like to say there is a temperature variation of plus or minus 1 degree. Okay, it is possible, and I can indicate and understand that there will be variation was around 27.5 degrees, or okay, the minimum was 25.5 degrees Celsius, because I took this plus or minus, okay, and there was an addition or deletion. So these kind of operations are possible on the ratio data. Okay, let's take example of nominal. What is nominal? Okay, let's take the difference between the ratio data and the nominal one. Now let us take your own ID. Okay, if I take BITS Pilani ID number, okay, what is that? So ID number, so something like this, 2017, is it 2017 or how does it start? 2017, then there is a code related to the branch, then there is a code related to or the your own number, and then followed by the code related to which campus you are studying, correct? That's how it is. Hold together it is, say this is A7 PS 001 and U. So this consists of both numbers also, and so it creates an alphanumerical value all together, so the complete code itself. Now these kind of numbers form nominal values. Okay, so when you would like to store these things, they form. So another one is zip code. Suppose you take zip code of a city, then that also creates your nominal value. So these are the creation. Now let us take an example of your ID number, and then let's try to perform some kind of operation on these data. Okay, let us say I would like to say there are more admissions are going on. Okay, the last one number was say 2017 A7 PS 00 say or 100, something like this. Okay, after that there is additional more number of students who are taking the admission, and then I would like to create next number. Okay, next number, can I add the value 1 here, okay, and generate the next number? Is it possible? I would like to just add the number, because as the admissions are progressing, I would like to generate this ID number in a progressive manner. Okay, so I would like to generate the next one, so it will be assigned to the. So how do I do that one? Addition of these values, is it allowed? Huh? Yes. So how if I add this one, where it should be added? So is it added to the 2017, or is it added to the PS? Which place it should be added?
To the 100.
100. Are you sure that it is? Like if I write it 2017 A7 PS 0101U. Okay, suppose it is resulting like this. Suppose for some reason this number is considered as invalid on that year for some reason. Okay, so this is not included for any of the student. It's not given to any of the student. In that case, what we supposed to do?
We keep adding 1.
Yeah, we keep adding 1. Okay, now this addition does not guarantee you whatever the ID number you are generating is valid for your purpose. Okay, when you just add 1 number, okay, so whatever the operation you can perform, so you can perform on 2017 or here or at the last 3 digits, but the resultant may not be a required ID number. Okay, therefore you cannot define the plus here. Okay, but it may generate the next in terms of the sequence. Suppose if I have all the list of possible ID numbers, and it was taken from that pool of ID numbers, it is possible in that case. So as a nominal data, there are some operations which are restricted on the nominal data. Okay, not all the operations are valid for the nominal data. So even if you take for example zip code of a city, okay, and then if you would like to add 1 or 2 on that one, and then you assume that it is a valid zip code of another city, it may not happen. Okay, some of the zip codes are omitted from the entire list and not assigned to any of the cities. in that case you will end up in identifying some zip code which is not valid. Okay, so all the operations are not defined, few of them are defined based on the type of data. So ultimately when you perform the operation, they should result in valid identity number. Okay, then only you can able to use that. Okay, and what will be the interval type of data? Data which is given an interval. Okay, suppose if I would like to describe the temperature, okay, then you need a interval. Okay, the temperature variation was between 26 to 29 degrees Celsius. Suppose if I give that variation, then I use the interval data. Okay, so that's how you, what is your CGPA? Okay, if I would like to say 0 to 10, okay, that's the interval what data it is creating. So there are so many examples in which you have to describe the data in terms of interval. So what are the ordinal data? Ordinal data has an implicit order in it. Suppose if you take a t-shirt size, okay, or shoe size, they have a different numbering system. Along with the numbering system, they are also given like XL, correct, L, large, medium, and so on. So they indicate the order. Suppose you would like to order them together, you can say that minimum is small, then goes for the medium, then goes for the large and XL, and so on. So there is a implicit order is possible in the case of ordinal data. Okay, so what kind of operations are possible on the ordinal data? Increments is possible. Suppose I would like to go for, what do you mean by increment? Does it like +1?
Next level.
Next level. If you would like to identify the next, yes. So if it is sorted in one order, then I can identify that okay, this is the order in which it is sorted and all these things. So there are several operations which are not valid for the given type of data. Okay, few of them are valid and few of them are not valid. So these are the operations. If I go for distinctness, order, addition, multiplication, so some of them are allowed and some of them are not allowed on the type of data, depends on the type of the data. So these are the columns which are giving with the examples, okay, and what type of operations are allowed. Okay, now if I take a look at nominal, the best example, if you really remember about like zip code or ID number, alphanumerical characters. Okay, so that those are the things which create your nominal data. So operations like, yes, you can identify the frequency. Okay, so given a table, how many times the given zip code is occurring in that table, that will be like identifying the frequency of that particular data. So those are valid. Okay, so next one, correlation. You can identify what is the correlation between one data with another one. Okay, that's possible with the nominal data. The ordinal data is a kind of there is a order like better, good, better, best. Okay, that is a kind of order it gives you. Okay, also your grades like A minus, there is a order exists, A minus, B minus, B, there is a order. Again, all type of operations are not valid. Okay, some of them are valid. Median, percentile, rank, correlation, okay, run test, sign test, all these are valid on the ordinal. Okay, interval are the one which are describing in between the interval. Suppose you perform the addition on one side of the interval, it jumps to the next one. Therefore, it is possible to perform the addition. Okay, so something like the temperature is a one which is good example for the interval. Okay, ratio, all type of operations are, maximum type of operations are performed on the ratio. So they are describing the numerical like measurements, length, width. Okay, so all these are described by ratio type of data. Okay, so these are the, again it is describing about the different operations which are possible and few more extra information in this slide. Okay, so nominal, ordinal, interval, and what kind of equation can be formed with the help of the data that is given.
This presentation was on data, type of data, and various operations on data. Thank you for listening to this presentation. Thank you.